penuh kesungguhan. Akademi Youtuber Malaysia, rangka laksana dengan jitu, penuh bermisi guru AYU, mencapai misi yang satu, bermisi kita bantu.
Tahniah. Siaran langsung ini dibawakan khas kepada anda oleh Akademi Youtuber Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Sirih berlipat, sirih pinang berasal dari Pulau Mutiara. Pemanis kalam, selamat datang. Awal bismillah, pembuka bicara. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera, salam Malaysia Madani dan selamat datang ke tuition online percuma bagi subjek Fizik SPM untuk tingkatan 4. Saya Cikgu Hasnitah dari SMK Bagan Jaya akan menemani anda pada malam ini lebih kurang 1 jam untuk satu lagi tajuk tingkatan 4 iaitu 5.7 Electromagnetic Wave 5.7 gelombang elektromagnet. Kelas ini akan disampaikan dalam bahasa Inggeris untuk DLP, tapi bagi yang bukan kelas DLP anda boleh juga mengikuti kelas ini kerana slide yang akan cikgu gunakan sebentar nanti adalah dalam dua bahasa. Okey, baiklah, seperti biasa sebelum kita bermula, ayuh kita mulakan dengan doa belajar dan umul kitab. Kepada yang bukan beragama Islam, anda bolehlah bertafakur mengikut kepercayaan masing-masing. Al-Fatihah. Amin, amin ya rabbal alamin. Okey, jadi sekali lagi selamat datang kepada semua guru dan murid-murid di mana jua anda berada dari seluruh Malaysia. Cikgu doakan anda sentiasa sihat walafiat. Okey, sebelum itu cikgu nak maklumkan di bahagian video description ataupun pada pin message, cikgu ada pinkan link untuk anda download, muat turun dan cetak keluar. Boleh digunakan bersama-sama dengan kelas ini. Okey, kalau tak sempat download, tak sempat cetak, tak ada masalah, no problem. You can do it later, follow this lesson first. Kemudian you boleh dapat jawapan penuh bila-bila masa. Anda boleh tonton semula ulangan bagi kelas ini. Kita ada Muhammad Husaini di sana. Waalaikumsalam. Terima kasih join kelas pada malam ini. Adakah Muhammad Husaini guru ke atau murid? Boleh perkenalkan diri tak? Okey, terima kasih bersama-sama dengan Cikgu Hasnitah. Okey, mana lagi anak-anak murid saya dari Bagan Jaya? Boleh say hi dekat live chat. Okey, jadi tanpa membuang masa, ayuh kita mulakan kelas pada malam ini. InsyaAllah mudah-mudahan kelas pada malam ini mendapat rahmat pada Allah SWT dan juga dapatlah membantu anda dalam memahami tajuk 5.7 ini dengan lebih baik. Untuk calon SPM yang saya percaya kebanyakannya telah habis menduduki peperiksaan percubaan, anda boleh gunakan slot ini juga sebagai slot ulang kaji. Okay, hi Joris, thank you again for being here. Really appreciate your present. Okay, jadi kalau sudah sedia, ayuh kita bermula. Okay, sebelum itu ini adalah kelas bagi tuition online dalam talian percuma bagi subjek Fizik SPM oleh Akademi Youtuber telah disampaikan pada Jumaat yang lepas. Kelas Core A+ bagi calon SPM oleh teacher Slinda yang membincangkan tajuk daya dan gerakan dua. Sekiranya anda terlepas kelas ni, tak ada masalah, boleh tonton semula ulangannya di channel teacher Slinda. Okay, dan untuk malam ini saya Cikgu Hasnitah akan teruskan untuk subjek tingkatan 4 5.7 5.7 Electromagnetic Wave. Kepada yang baru pertama kali mengikuti, sebenarnya kita telah bersiaran sedari tahun 2020 untuk kelas tuition online percuma, dan kalau anda ikuti di portal Akademi Youtuber ada banyak lagi subjek yang lain. Okey, cikgu perkenalkan barisan ahli panitia fizik di Akademi Youtuber yang telah banyak membantu saya untuk menerbitkan video-video PDPC untuk fizik tingkatan 4 dan 5, sama ada untuk kelas DLP ataupun bukan DLP. Dan cikgu-cikgu ini juga telah banyak membantu saya menjalankan kelas tuition online percuma untuk murid-murid di seluruh Malaysia. Okay, kepada siapa yang belum lagi muat turun apps Akademi Youtuber, boleh muat turun di Android anda sekarang juga. Apps ini memuatkan sehingga hari ini lebih daripada 26,000 video PDPC daripada pra-sekolah hinggalah ke pra-universiti. Mudah-mudahan usaha daripada sukarelawan Akademi Youtuber ini membantu guru-guru dan murid-murid dalam memperkaya bahan-bahan PDP di sekolah. Okay, jadi mari kita bermula. Without further ado, let us begin with our lesson. Before that, can I have some response to you? If you are good and ready to go, can you type 1 in the live chat, students? Kalau anda sedia bermula, type nombor 1 dekat live chat. Okay, then we can go with the first learning standard on characterize electromagnetic wave. Yes. Okay, thank you for your response. Okay, so we take a short look on the history of electromagnetic wave. Kita tengok sekali seimbas lalu apa sejarah gelombang elektromagnet ini. So if you look, actually this one taken from your physics textbook. Okay, on 1801. Okay, it started with Thomas Young. Okay, hi Chia Yao, thank you for your response. Okay, Thomas Young has shown that light is a wave through experiment on interference of light. Okay, kalau anda belajar interference, okay, we have two experiment involving Young. First is Young single slit on diffraction of light, and also Young's double slit experiment to study interference of light. Okay. And then later on 1862, it was continued by James Maxwell, who put forth on the theory that light is an electromagnetic wave. Okay, Sarmila, thank you for being here. Really appreciate your time. Okay, and then later on 1887, we have another German physicist, Heinrich Hertz, which generate a different kind of electromagnetic wave, that is a radio wave. Okay, and then in earlier 20th century, it was continued by the following physicists, and they have found that electromagnetic waves are made of these component as gamma ray, X-ray, violet ray, visible light, infrared, microwave, and radio wave. So later we are going to look in detail for all these 7 spectrum of electromagnetic wave. Okay, now what is electromagnetic wave, students? From the name itself, actually it tells you it is a combination of electric field and magnetic field that oscillate perpendicular to one and another. So we define electromagnetic wave as written here. Okay, EM or electromagnetic wave are made up, or it is a wave which made up of an electric field and magnetic field that oscillate perpendicularly to one and another, as shown in the GIF here. So there are 2 important keywords there. First, it is consists of electromagnetic field. It is consists of electric field and magnetic field. And the second keyword, they oscillate perpendicularly. All right. Okay. So next. Okay, now let us take a look at the characteristic of electromagnetic wave. There are 7 characteristics which you must know and understand very well. So the first characteristic, all electromagnetic wave are transverse wave. So just now you see at the history slide, there are 7 spectrum of EM wave. They are all transverse wave. Okay. Second, they do not require any medium to propagate, mean they can travel everywhere. All right, they can propagate through vacuum as well. Okay, and then the third characteristic, all electromagnetic wave have a speed in vacuum which is equal to the speed of light. 3 times 10 to the power of 8 meter per second. Okay, and they move with lower speed in any medium. So in vacuum, students, in vacuum, all EM wave travel with the same speed, 3 times 10 to the power of 8 meter per second. Okay, and the fourth characteristic, same as water wave, light wave, sound wave. So all electromagnetic wave transfer energy from the when they propagate from one point to another. So this is the general characteristic of any wave. They transfer energy without transferring matter. Yes. And the fifth characteristic, they carry no charge. Okay, all EM wave are neutral. They carry no charge as they propagate. And the wave equation is applicable for all electromagnetic wave. You learned this before, the wave equation to determine speed of wave. V equal F lambda. Okay, so since all EM wave travel with the same speed in vacuum, so we replace V with C. C is speed of light. Okay, C equal F lambda. Okay, so C is constant. 3 times 10 to the power of 8 meter per second in vacuum. And the next characteristic, last but not least, all EM wave show the same phenomena. All can be reflected, all can undergo refraction, diffraction, and interference as well under suitable conditions. Okay, so these are all 7 characteristics of electromagnetic wave. Okay, so who's clear with the first learning standard? Can you type number 2 in the live chat, student? Okay, so in the first learning standard, we learn what is the definition for electromagnetic wave and also the example and characteristic of electromagnetic wave. Okay, thank you very much for your response, Mr. Madan Mohan. I really appreciate them. Okay, now let us move to the second learning standard, students. Okay, in the second learning standards, each and every one of you must know how to state the component of electromagnetic spectrum according to their wavelength and frequencies. All right. Okay, let us take a look. Okay, if you look or open your textbook, you will see this diagram. This is a diagram shows that the electromagnetic spectrum started from gamma ray on the very left side, ended with radio wave on the right side. Okay, if here you see the number, they give a number as well. Number 1 on the very left, very right side is radio wave, followed by microwave, infrared, and then we have visible light down here, number 4. Number 5 is ultraviolet ray. Number 6 is X-ray, and number 7 is gamma ray. Okay, okay then. What is frequency? What is frequency? Actually, you learn frequency before in the earlier part of this chapter. Okay, what is frequency? Frequency is the number of complete oscillation in 1 second. Okay, tam, mau, kai. It is referred to the number of complete oscillation in 1 second. Okay, for example, if the frequency is 10 hertz, okay, so the wave has 10 complete oscillation in 1 second. If the frequency is 50 hertz, okay, for example, there is a wave, light wave with frequency 50 hertz, it means there are 50 complete oscillation is produced for every 1 second for that wave. So I hope you're clear with that. Am I answering your question? Okay, so we go back to this slide, students. So if you look at this electromagnetic spectrum from radio wave to gamma ray, they are aligned according to their increasing frequency. Okay, so from radio wave to gamma ray, the frequency is increasing. And when we talk about wavelength, it is the opposite side. Okay, if you talk about wavelength, Okay. Wavelength is inversely proportional to frequency, which means radio wave has a very short frequency, so it has the longest wavelength here. The wavelength is increasing from the left to the right, while the frequency is increasing from the right to the left. So for example, gamma ray is an electromagnetic spectrum with the highest frequency and the shortest wavelength. Okay, while radio wave is an electromagnetic spectrum with the lowest frequency but longest wavelength. Okay, thank you very much, Tam Mau Kai. Okay, may I know which school you are from? Okay, then if you look at number 4 here for visible light, student, visible light, it is can be separated into 7 color of spectrum. Okay, as you usually seen on a rainbow. Okay, it started with the red here with the longest wavelength of 750 nanometer, followed by orange, yellow, green, blue, indigo, and violet. All right. Okay. Okay, then. So how to remember the position? Okay, where to place radio wave, microwave, infrared, visible, and so on. I normally use this what do we call abbreviation. Okay, R is for Ronaldo. Okay, since I love football or soccer very much, so I use these terms. Ronaldo, may I visit your ex-girlfriend? Okay, again, Ronaldo, may I visit your ex-girlfriend? Okay, Ronaldo is for radio, may is for microwave, I is for infrared, visit is for visible light, your, okay, ultraviolet, X-ray, girlfriend, gamma ray. So again, Ronaldo, may I visit your ex-girlfriend? Or can you share with me what techniques or what tips you are using to memorize the sequence of all these electromagnetic spectrum? If you don't have yet, maybe you can use mine. Okay, Ronaldo, may I visit your ex-girlfriend? Simple, right? Yes. Okay, now students, let us look in detail. Okay, thank you very much, Mr. Madan. Okay. Okay, then let us take a look at each of these EM component in details. Okay, so from radio wave to gamma ray, the frequency is increasing, but the wavelength is decreasing. Okay. Okay, so this is the point to understand this. Okay, first you must know there are 7 types of electromagnetic wave which form a continuous spectrum. So they are known as electromagnetic spectrum. Right? And second, these electromagnetic spectrum arrange in increasing frequencies and decreasing wavelength from right to the left, as I showed you before. And then third, the energy carried by electromagnetic wave is directly proportional to its frequency, which means if the frequency is higher, so the amount of energy carry also higher. So we can say gamma ray carries the highest energy due to its highest frequency. All right. Then, the fourth point here, gamma ray and X-ray carry large amount of energy. So this is the example. These waves need to be handled properly as not to endanger the users. So that's why when handling gamma rays and X-ray, we need extra precautions since they carry a lot of high energy with them. Okay, that is the second learning standard. All right, we have seen in details how the 7 electromagnetic spectrum are arranged according to their increasing frequencies from the right to the left. Okay, while the wavelength is the other way round. All right. Okay, now the third learning standard. Okay, so are you okay with the second learning standard? If you do, can you type number 3? Can you give me number 3 there? Okay, for those who missed the first part of this lesson, never mind, you can come back later anytime you are free to get the full answers for the PDF copy I shown in this video description below. Okay, thank you very much again, Mr. Madan Mohan. Okay, now let's move to the third learning standard student. Actually, this is the last learning standard. There are 3 learning standards only in this content standards 5.7. Okay, how to communicate, student? The third learning standard, you must know how to communicate, to explain about the application of each component in the electromagnetic spectrum in our daily life. So if you ask me, this will be the gist of this content. Where do we apply radio wave? Where do we use microwave, infrared, and so on? Okay, the applications in human daily life. All right. Okay, so first again, this actually was taken from your textbook. So while following this lesson, you can also open your textbook if you have them with you. Okay, so this is the table, shows to you the characteristic and application for radio wave. So where is the sources of radio wave, student? Radio wave, the sources is from the radio and television transmitter. Okay, from the electrical oscillating circuit. Okay, so this is the characteristic of radio wave. It carry audio and visual information. For radio, you can only hear an audio, but for television, you can see both. It carry both audio and visual information. Okay, so it is consist of long wave (LW), medium wave, short wave, very high frequency, ultra high frequency wave, depend on its purposes. Okay. As for example, in radio, if you listen to a radio, you will see there is AM, FM, okay, fly FM, hot FM, cool FM. We also have AM, which is normally in the urban area. Amplitude modified, FM is frequency modified. All right. So what is the application of radio wave? Radio wave used a lot in long distance radio communication. Okay. Second, it is used in local radio and TV broadcasting. Okay, local. And also used in wireless communication, for example, in Bluetooth, Wi-Fi, Zigbee, and Z-Wave. I'm not familiar with these two. Maybe it is used in another country, but in Malaysia, normally we heard Bluetooth and Wi-Fi. Also used as millimeter wave machine to scan the body of a passengers of the airport. So for those who are normally on board, there is a scanning machine in the airport which is used radio wave to scan the body of a passengers as shown in diagram down here. All right. Okay, so that is for radio wave. Okay, and then second we have microwave. Okay, microwave. Where is the sources? Microwave is from radar transmitter, microwave oven. Okay. So what is the characteristic of microwave? It can penetrate the atmosphere. Okay, suitable for satellite communication. It causes a very quick heating by supplying energy to water molecule in an object to vibrate vigorously at the frequency of microwave. So this is how a microwave used to cook food in a microwave oven. The name also given because that oven used microwave to cook food. Okay, application for microwave, number one, it is used as international communication through satellite. For local communication, we use radio wave, but for global or international communication, we use microwave. Okay, second, mobile phone framework. Okay, communication between electronic devices, okay, between one device to another, so it is using microwave. Okay, detection of plane radar and speed trap. And next, cooking using microwave oven, as I mentioned just now, and also in GPS, Global Positioning System. Okay, GPS. So if you are using Google Map or Waze, so actually you are using microwave. Okay, next we have infrared, students. So where is the sources? Any warm or hot bodies produce or emit infrared, even our body. Okay, human body emit infrared. Okay, and the first sources, of course, coming from the sun and also fire sources. Okay, what is characteristic of infrared, student? Number one, it is also known as infrared radiation. Okay, when an object absorbs infrared rays, its temperature increases, becomes hotter. Okay, so infrared used where? Number one, for cooking. Okay, using oven, grill, and toaster. Okay, this one is not microwave oven. The normal oven use infrared. Okay, for night vision. Okay, night vision, for example, infrared camera or infrared binoculars. Okay, and also used to drying paint on car. Treatment of muscle pain. Okay, used in medical field as well, and also in remote control device for television and DVD player. Okay, remote control of a car also use infrared. Alright, okay. Next, visible light. Okay, visible light coming from the sun, the main sources, hot object, light bulbs or fluorescent tube. Okay, visible light. Okay, consists of 7 components: red, orange, yellow, green, blue, indigo, and violet. Okay, Roy G. Beef, this one, Roy G. Beef. Okay, then application for visible light, enable living things to see. Okay, so we can see things due to visible light. Okay, second, it is used a lot in photography, photosynthesis in green plants. Okay, a laser light also use visible light in cutting of metal, measurement of land, and sending information through optical fibers. Okay, so these are some example of uses of visible light. Okay, then we go to UV, ultraviolet. Okay, ultraviolet from very hot bodies. The sun is the main sources, and also mercury vapor lamps, okay, in the hospital. Okay, so the characteristic, it can be absorbed by glass and the ozone layer in the atmosphere of the earth. Okay, and exposure to small amount is good for producing vitamin D in our skin. So this is the benefit for UV. Small exposure is supply vitamin D to us, but for an extra exposure or exposure to a large amount can cause eye cataract and skin cancer as well. So if you notice, those people who live around Kathmandu, okay, most of the residents there, especially the elders, they suffer from cataract. Okay, since they live in a very high ground, so they are very close to the sun. So exposure to UV light in a year is very high. Okay, so according to the statistic, a study conducted there, most of the elderly there suffers from eye cataract, formation of white layer due to the excessive exposure to ultraviolet. Okay. So where do we use UV rays, students? Number one, it is used as a hardened tooth filling material. Okay, and to determine authenticity of a currency notes. So to detect counterfeit notes, wang palsu, so we are using ultraviolet. And maybe you notice in a cashier counter in some supermarket, they use UV light to detect the authenticity of notes. Okay. Then treatment of jaundice in baby. This is applied in hospitals. purification of drinking water, and also to sterilize surgical instrument and food. Other than that, it is also used as an insect traps. Have you ever go to kedai mama to watch football? I think I believe you used to see this pest killer, okay, which is used ultraviolet ray to trap especially mosquito and flies. All right, okay. Okay, now we move to X-ray, students. X-ray. So the sources from X-ray tube and outer space bodies. All right. Okay, what is the characteristic of X-ray? Number one, it has a high energy, very high energy because of the very high frequency. It also has a high penetration power and very dangerous, okay, when exposed to it. So we use X-ray for what? Number one is to detect fractures or broken bones and examine internal organs, okay, of human or animals. Second, it is also used to check the welding connections in metals and also to detect cracks in building structures. Also used as a baggage scanning at the airport. Okay, to scan the passenger, we are using what we are using just now. Then for scanning the baggage, we are using X-ray. All right, and then to determine authenticity of paintings, okay, we are using X-ray to determine either the paintings is original or fake. All right, okay, and next, last but not least, gamma rays. Okay, gamma rays. So gamma rays is electromagnetic wave spectrum with a very high frequency. So it has a very high energy, high penetration power, and dangerous as X-ray as well. So the sources, it came from radioactive substances and also from cosmic rays. Cosmic rays is the rays coming from the nature, right, around us. Okay, what is gamma ray used for? Number one, I believe you know this very well, used to kill cancer cells in radiotherapy. Okay. Second is to sterilize surgical and medical equipment in bulk amount, dalam jumlah yang besar. Okay, for small amount enough to use ultraviolet, but in a bulk amount we are using gamma rays. And also used in food processing industry, so the food can last longer, especially in canned food. So the food can be last for 2 to 3 years. Because when they are exposed to gamma ray, it will inhibit the growth of microorganism inside. All right, and also used in as pest control in agriculture. All right. Okay, so that's all the application for all the electromagnetic wave component. So what if we take a short break for a while? So when we come back, we will try to do a few exercises, and some of them are SPM or SPM trial paper involving electromagnetic wave. Okay, don't go away. We'll be right back after this short break. Okay, welcome again to our physics free online tuition brought to you by Akademi Youtuber Malaysia, Kelab Guru Malaysia dan e-didik Malaysia. I'm Cikgu Hasnitah from SMK Bagan Jaya, Butterworth, Pulau Pinang, your presenter for this evening. Okay, so are you ready to begin with the exercises? So now let us discuss a few example of questions related to electromagnetic wave. Okay, so the first one, we check on the example of objective question first. Okay, can you respond to me? What is the answer for the first question? Diagram 29 show a device to detect fake notes. Okay, so what type of EM spectrum? When I say EM, I hope you understand that is referred to electromagnetic. Okay, so what is the type of EM spectrum does the device use? Okay, we just discussed this before the short break. Remember, to detect counterfeit or fake notes, which one? Is it A, infrared? Is it B, microwave? Is it C, ultraviolet? Or D, gamma rays? Okay, you can give me your response by typing your answer in the live chat. Come on, everyone. Okay, which one? To detect fake or counterfeit notes. Yes, very good. Answer is UV, ultraviolet. Okay, ultraviolet. Okay, what about the second question? It shows a satellite dish. Okay, satellite dish. So which wave the satellite dish function using which type of EM spectrum? Is it gamma ray? Is it microwave? Is it radio wave or infrared? Actually, the keyword there is satellite. Remember, satellite communication using, yes, very good, using microwave. Okay. Next question. Okay, diagram 22 shows electromagnetic spectrum of waves. So they give you from gamma ray on the left and radio wave on the very right side. Okay, the question is which physical quantity decreases from gamma to radio wave? So you can underline or highlight the point of this question. Which physical quantity decreases from gamma to radio wave? Okay, student, which one? So you only have two answers, either wavelength or frequencies. So which one? It say decreases from gamma ray to radio. So answer frequency. Okay, remember just now gamma is the EM spectrum with the highest frequency, while radio wave with the lowest frequency. Okay, yes, thank you for your response. Tam Mau Kai. Okay, next. Okay, diagram 33 shows an application of EM wave. Okay, so you can see this is the diagram. Okay, which statement is correct about the characteristic of the wave used? Okay, so first you must know this is the wave which is used to examine the bodies of a patient. Okay, or examine the bones. So I believe you know that is X-ray. So first you must know the type. Okay, type of X-ray. Remember just now all EM wave are transverse wave. So you can cancel A and D readily. So it is either B or C to consider. Okay, so the frequency for X-ray, remember X-ray has a high or low frequency. So it has high frequency. Okay, what about the energy? It also has high energy. So the answer is definitely C. Transverse wave, high frequency, and high energy. Easy, right? Okay. Okay, now we move to the next question, student. Okay, diagram 20. I'm sorry, I forgot to place number for this question. Okay, okay, question number 27. This is a drone. Okay, and a remote control. So they give you table 2 to show the spectrum of EM wave. Okay, gamma ray, and then we have P, Q, visible light, R, S, and radio wave. Okay, so the question is which EM wave is used by the remote control, student? I believe you know that is infrared Okay, but now where is the position of infrared there? So this is where we use the Ronaldo just now. Ronaldo, may I visit your ex-girlfriend? So which one? Ronaldo, may I? So invisible infrared. Okay, this is R. Okay, which one? Ronaldo, may microwave. Is it? Okay, for drone. Okay, next. Is it R or S? I think the answer here is R. Okay, infrared for remote control. All right, so it should be, I think it should be R. Okay, Ronaldo, may I visit your ex-girlfriend? Infrared. All right, okay. 26 student, this is for television. Okay, television. Okay, television. Okay, so which one for television? Okay, so for television, remote control for television, it is infrared. Okay. Okay, are you clear now? I think for the drone, okay, so, oh, sorry. Before that, sorry for my mistake. Okay, for this remote control, we are using it for drone. Okay, since drone travel in a long distance, okay, so we prefer to use a microwave instead of infrared. So that's why here the answer is S. Okay, so correct for my mistake. But for this TV and radio remote control, yes, we are using infrared since it is for short range of sensor detector. Also remote control for a car, we are using infrared. Okay. Okay, now let us move to the structure and essay question. Okay, so again, for those who have joined us, you can find this module. I have pinned them in the live chat. Also, you can find them in the video description below. So anytime you can come and click them, download and just print out for free. Tak perlu bayar, all for free. Okay, I hope it help you to understand this topic in a better way. Okay, we move to soalan percubaan SPM 2022 from Pahang State. Okay, so this is the diagram you are given. Diagram 2 shows radio wave used in television broadcasting station for local broadcasting. Okay, remember for local broadcasting, we are using radio wave. For global or international communication, we are using microwave. Okay, so the first question, state one characteristic of radio wave, student. So one characteristic of radio, okay, since radio wave is EM wave, so you can give any one of the 7 characteristic I discussed earlier in this lesson. So example, you can write, it is a transverse wave, do not require medium to propagate, travel through vacuum with speed of light of 3 × 10⁻⁸ meter per second. It shows reflection, refraction, diffraction, and interference. Also, it comply the wave formula of V = F lambda. So you can choose any of these characteristic. Okay, B. The frequency of the radio wave emitted is 2.5 × 10⁸ hertz. Okay, sorry, wrong typing there. Supposed to be 2.5 × 10⁸ hertz. Calculate the wavelength of the radio wave. Okay, how to find the wavelength? So we can apply this equation. So this is the equation. V = F lambda. Remember just now V is 3 × 10⁸. Okay. It is the same for all EM wave when they are traveling in vacuum or in air. So this is the frequency given. So from here, we can find the wavelength or lambda. It's just a simple mathematics. So when you solve, it will be 1.2 meter. So if this question allocate 2 marks, the first mark is given on the substitution and the second mark is given on the answer together with the unit. Okay, so don't forget to write your unit meter. Okay, C. Question C. Name the wave phenomenon involved and explain it happened. Okay, first it say radio wave transmission from the television broadcasting station in this diagram is blocked by hills or tall buildings. So this is the problem. The wave can still be received by the receiver of the wave signal even though it is blocked, but the community still can receive the signal. So name the phenomenon occur and explain why it can happen. If you remember, we learned this in a previous chapter, a previous topic. So the phenomenon is, yes, diffraction. Okay, diffraction. And how to explain what happened in diffraction, student? Wave will be bent when passed around. Okay, an obstacle or spread after passing through a gap. So you can give the definition for diffraction. The wave will be spread after passing through a gap or an edge of an obstacle. Okay, very good. Okay, now Selangor Set 2 2022 percubaan. Okay, you are given diagram 8.1. What is meant by EM wave? Now asking for definition. Remember the two keywords just now. It is consist of electric field and magnetic field which oscillate perpendicularly to one and another. Okay, so this one, EM wave are made up of electric field and magnetic field oscillate perpendicularly to one and another. Okay, now they give you table 8, 3 example of electromagnetic wave spectrum. Infrared used in remote control. Okay, radio wave used in radio, and W used in radar system. Okay, do you remember just now in the third learning standard, the application, which EM wave is used in radar system? Okay, who remember which one? So what is wave W, radar system? Yes, very good. Answer is microwave. Okay, microwave. So state one reason why we use microwave in radar system. What is the advantage or benefit of using microwave here? Yes, it has high frequency, or you can say it can penetrate through atmosphere. Okay, it can penetrate through atmosphere. Another answer given here, it can penetrate through rain, it can penetrate through snow, or it has high frequency. Okay, high energy. Okay, next. Okay, this one, question C. Okay, 8.2 diagram. Communication system involved in transmitting information between two distant location. So the keyword is two distant location, communication. Okay, so what type of wave is transmitted? Okay, what type? Yes, again, it is microwave. Why we are using microwave in distant communication? Again, it is because it has a high frequency, or it can penetrate through atmosphere. Okay, and then the diameter of the receiver. Okay, so since this is question A, so you have to give suggestion. Okay, so what about the diameter of the receiver? Better to be big or better to be small? So just think logic. So yes, larger, bigger. Okay, why? Why? Why the diameter of the receiver better to be larger or bigger? So that it can capture more signal, or it can reflect more signals. Okay, what about the location of the transmitter and receiver? Where to place, student? See the transmitter and the receiver, where to place them? The location. Yeah, we place them on a high position. Where? At the top of the hill. Okay, in higher ground. Okay, you can say also at a higher ground, on top of the hill. Why higher ground? Think logic. Yes, so that the signal won't be blocked. Or also you can say it has a wide receiving range. Okay, wide receiving range, or you can say signal not blocked. All right. Okay. Okay, next. Now Sarawak. Okay, 2022, set number 3. Okay, now we have microwave oven. Okay, microwave oven. again what is meant by EM wave. So the question is repeating and repeating. So I hope by doing the question repeatedly, you will have a clear definition on EM wave. So what is EM wave? Very good. It is a wave which made up of electric field and magnetic field which oscillate perpendicularly to one and another. Yes, very good. Okay, now B. And this is a 4 marks essay question. Okay, how to handle. Explain how food can be heated in the oven as shown in diagram 4. So this is not in the slide I discussed to you just now. So you must think how to elaborate your point to get 4 marks. So first you must have the concept that is crucial. Okay, so how to say? So you can say point number 1, high frequency electromagnetic radiation is emitted. Okay, it emits microwave, which is high frequency wave. Okay, second, the water molecule in food absorb this microwave, or the water molecule in food absorb this electromagnetic radiation. So what happened? Molecule vibrate and produce heat. So by that, the water molecule vibrate and produce heat. And last but not least, this heat is used to increase the temperature of the food and finally cook them. Okay, are you clear? So first it emits microwave, which is a high frequency wave. Second, the water molecule inside the food absorb this microwave or electromagnetic radiation. And third, what happened after it absorbed? The molecule vibrate, okay, and producing heat. So the heat produced increase the temperature of the food and finally cook them. Okay, simple. Okay, now C1, you have to calculate. Calculate what? Frequency of the wave when they give you the wavelength and the speed in vacuum, which is 3 times 10 to the power of 8. So this is simple calculation, right? Just apply this equation for wave speed equal frequency multiply wavelength. All right. Okay, so this is the speed. So we are looking for the frequency. So this is the wavelength. Again, simple mathematics, right? So the answer is 1 times 10 power of 10 hertz. Okay, 1 times 10 power of 10 hertz. So 2 marks, first mark on the substitution here, second mark on the correct answer. Okay. Okay, next. Okay, number 2. When this microwave propagates in water, what will happen to the frequency, wavelength, and speed of microwave, student? So just now they're traveling in air. Okay, suddenly it went to water. So the medium is changing from air to water. Okay, so this is the situation. Now the wave traveling from air through to water. So 2 different mediums. So what happened to the frequency? What happened to the wavelength? And what happened to the speed of microwave? So first you must understand what is the phenomenon involved when microwave traveling through 2 different medium. Okay, can you give me the name of the phenomenon? Boleh bagi cikgu tak apa nama phenomenon involved here? Okay, why do water molecule vibrate? Okay, since when they are absorbed, this EM wave, the wave carry energy, mean the water receive energy. So when they receive energy, that cause them to vibrate. Okay, so when they kinetic energy increasing, the temperature also increasing. So this increase the temperature of the food. Okay, are you clear? Tam, Mau, Kai? Okay. Okay, am I answering your question? I hope I do. Yeah, very good. Okay, now this one. Can you give me the phenomenon when the microwave traveling from air into water? Yeah, very good. The phenomenon is refraction. Yes, very good. Thank you, Mr. Madan Mohan. So remember when we study refraction, what happened to the frequency? Does the frequency changes? No, right? Why? Because the wave is from the same source. What about the wavelength? Is it changes from air to water? What happened to the wavelength? Yes, wavelength changes, and also the speed of the microwave. It is increases or decreases? Okay, so answer, frequency remain unchanged because same source of wave. Okay, the wavelength decreases, so do the speed decreases. Okay, why decreases? Because water has a higher optical density compared to air. So microwave travel at the low speed in water, so the wavelength also decreases. Okay, since speed is directly proportional to wavelength if according to this equation. Okay. Okay, next. Okay, this one. I think this is the last question for this evening. This is from SABK, if I'm not mistaken, from Model Mashhur. Okay, again, you are given diagram 4.1. It shows an electromagnetic wave spectrum. On the left side, we have radio wave, and then we have A, visible light, and then we have X-ray, and this end we have B. Okay, first question, define EM wave. So they ask you for the third time readily now. Okay, again, it is a wave. Okay, EM wave is a wave made up of electric field and magnetic field which oscillate perpendicularly to one another. Okay, so B, state the electromagnetic wave A and B and their uses. So now the name of the EM spectrum and its application. So A is microwave. Okay, microwave. How to know microwave? If you see here, how many lines we have? 1, 2, 3, 4, 5, 6, 7. So enough with the 7 spectrum. So again, Ronaldo, this one radio. May, so this one May, microwave. Here is infrared. I, visit, visible light. Here is ultralight, your, X-ray, X. B is gamma ray, girlfriend. Alright, okay, Ronaldo, may I visit your ex-girlfriend? So A is microwave and B is gamma ray. So what is the function of microwave? You give 2 marks. Okay, you can give, since it is 2 marks, so which means when you name A and B correctly, so you have 2 marks. And then when you give their users 1 for each, you get the 3rd and 4th marks. Okay, but here I give you 2. You can give more, but make sure they are all correct, so there won't be any conflict. All right. Okay, so microwave used for detection of plane radar and speed trap, or you can use in microwave oven. Okay, or you can say use in international communication or long distance communication. And B, we have gamma ray used for what? To kill cancer cells in radiotherapy, or also used to sterilize of surgical and medical equipment in bulk. Okay, means in huge amount. Okay. Okay, and then C, okay, now they give us remote control for a car. EM wave used in remote control to operate device such as television, car, and gates from distance by wireless. All right. So 4.2 diagram 4.2 shows remote control used to lock the car. Although person A is in between the remote control and the car can still be locked. Okay, so the first question here on diagram 4.3, draw the pattern based on the above situation. So first you must understand what phenomenon occur here. So when the infrared from this remote control traveling, so the person is actually act as a barrier. Okay, so what is the phenomenon when a wave have to pass through a barrier? That is diffraction. Yes, very good. So this is the barrier. So diffraction, so the wave will be spread from the both edges of the barrier. So we draw diffraction pattern for a wave passing through a barrier. Okay, don't draw the one that passing through a gap, because now the person act as a barrier. So this is the diffraction pattern for a wave passing through barrier. Okay, good. Okay, next. Okay, this one. Suggest type of EM wave used in the remote control and explain how the remote control works to lock the car. So we are using infrared for remote control. So you write infrared, you save 1 mark. So how to get the second mark when you explain. So how infrared is used in remote control, student? So first you can say the remote control act as a radio transmitter. Okay. So if there is a transmitter, so there must be receiver, right? So who's the receiver? Yes, the car act as a receiver. So when the button is pressed, imagine you are pressing the remote control, okay? When the button is pressed, so transmitter is turned on and it transmits radio wave at certain frequency to the receiver in the car. So by this, the receiver will convert the signal to activate the car lock system. Okay, simple, right? Okay. And then number 3, we have to calculate the wavelength. Given EM wave transmitted with this frequency, 20, this one you have to know how to read. Okay, 20 megahertz. Okay, mega. So mega is 10 power of 6. Yes, very good. Velocity. So find the wavelength. Okay, so what is the wavelength? So this is the equation. V equal F lambda. So this is the speed. So we have the frequency 20 times 10 6. Okay, 10 6 is megahertz. So by this, the lambda is 15 meter. Okay, 15 meter. Okay, so I guess that's all for tonight. We have discussed the 3 learning standard on 5.7 electromagnetic wave and also some example of exercises and SPM trial collection paper on EM wave. So I hope this session helped you to understand 5.7 in a better way. Again, thank you very much for your time, students, teachers. I really appreciate your presence. And this is as my token of appreciation. You can click on this link to get your e-cert for Sijil Express. Please fill up your name and IC number correctly. And the cert will be generated and sent to your email just in a blink. Okay, so you can keep them as a memento. So again, thank you very much for being here with me from 8:15 until now, 9:17 p.m. So I hope to see you again in our next session. But next week, we will be off for a while. Okay, because I have school activities to attend. So I'll see you again on the week before the school reopen. Okay, so thank you for being with me, Cikgu Hasnitah. Again, thank you very much for your time. I really appreciate them. Kita jumpa lagi dalam masa yang akan datang. Sesungguhnya yang baik itu daripada Allah, yang kurang itu daripada kelemahan dan kedangkalan ilmu saya. Semoga sesi ini bermanfaat untuk semua guru dan pelajar yang menyertai daripada awal sehinggalah kini. Jangan lupa saksikan kami lagi guru-guru sukarelawan AYU khususnya bagi subjek fizik setiap Jumaat 9.30 malam dan hari Ahad 8 suku malam. Tapi minggu depan kita cuti rehat sebentar selama 2 minggu. Kemudian kita akan kembali lagi dengan skor A+ SPM untuk tingkatan 5 dan kita akan mulakan tajuk yang pertama untuk chapter untuk bab 6. Light and optics. So stay tuned with us. Follow me, Cikgu Hasnitah, in my YouTube channel. Again, selamat malam. Jumpa lagi. Assalamualaikum dan bye-bye semua. Yeah, thank you very much, Mr. Mohan. Thank you very much, everyone. See you again in our next lesson. Assalamualaikum. Good night and have a good rest.
Mara semua para ilmuwan, semai ilmu kepada anak wawasan, tak kira di utara selatan, sampaikan ilmu penuh kesungguhan. Youtuber Malaysia, rangka laksana dengan jitu, penuh bervisi guru AYU, mencapai misi yang satu. Pervisi kita, bantu kita, bermoto sendiri yang kita biasa, bersama kita luar biasa, berjasa demi nusa bangsa.
Akademi Youtuber Malaysia, berpadu bersatu keluarga AYU, memberi ilmu tanpa jamu, siap sedia menyumbang ilmu.
Ilmu diberi juga dikongsi pada semua generasi yang terkini, lahir generasi yang berkualiti, sedia berkhidmat pada pertiwi. Akademi Youtuber Malaysia, rangka laksana dengan jitu, penuh bervisi guru AYU, mencapai misi yang satu. Pervisi kita, bantu kita, bermoto sendiri yang kita biasa, bersama kita luar biasa, berjasa demi nusa bangsa. www.academyyoutuber.com. Berusaha AYU capai kecemerlangan, berpadu AYU cipta kegemilangan, bersatu AYU bina wadah terbilang, terus berjaya bersama AYU.
Berusaha AYU capai kecemerlangan, berpadu AYU cipta kegemilangan, bersatu AYU bina wadah terbilang, terus berjaya bersama AYU.
Mara semua para ilmuwan, semai ilmu kepada anak wawasan, tak kira di utara selatan, sampaikan ilmu penuh kesungguhan. Akademi Youtuber Malaysia, rangka laksana dengan jitu, penuh bervisi guru AYU, mencapai misi yang satu. Pervisi kita, bantu kita, bermoto sendiri yang kita biasa, bersama kita luar biasa, berjasa demi nusa